Hello guys and welcome. It's Engineering Rebel, and in this video I'm going to be talking about how car engines work, the internal combustion engine. Now, this video will be broken up into three parts: the types of engine designs, the parts of an engine and what each part does, and the strokes of an engine. This video will not include the rotary engine because that works differently than your normal engine with a crankshaft and pistons. That video will be dedicated for some other time. So what are we waiting for? Let's just jump right into the video. So there are three types of engine designs. You have this one, which is an inline, you have a V configuration, and you have a boxer engine, or known as a flat motor. Now, an inline engine is a type of engine in which the cylinders are arranged in one row. So it's one next to another. The benefits of an inline engine are that it's very cheap to own, very cheap to maintain, and it's very easy to work on. The downsides of an inline engine are that because of its long design and that the cylinders are only in one row, it's not compatible with old cars. Because the engine is so long, it might not fit in some engine bays, therefore making it difficult to implement. But otherwise, it's a great sounding engine and a very nice engine for beginners and for people who like to wrench on their cars. Next up is the V configuration engine. Now this engine has a set of cylinders on each side. Now it's called a V configuration engine because when the pistons move up and down on each side, it's in the shape of a V. Now the upsides of this engine are that you essentially have the same number of cylinders as an inline engine, but because there's a set of cylinders on each side, it's much more compact, therefore making it easier to implement, and it could be universally used for any type of car. Now, the downsides are that it's much more expensive to maintain, more difficult to work on, and replacing some parts are just going to be much harder than your typical inline engine. Last but not least, the boxer engine. Now this engine is kind of like a V configuration engine, except it has a much lower center of gravity because the cylinders are laid on their side. So kind of imagine taking two inline engines, but instead of sticking them together in a V shape, they're laid on their side. The boxer engine does have a benefit of its own. Because the cylinders are laid on their side, it has a much lower center of gravity because the engine is more compact and isn't as tall as a V configuration engine. So the handling of the car is going to be much better because the center of gravity is lower. It's much harder to work on than a V configuration engine, if not the hardest engine to work on. Doing valve jobs or trying to get access of the engine from the sides is almost a nightmare, and in some cases has to be dropped out of the car. And therefore, it's going to be very expensive to maintain, and if you don't know what you're doing, it could turn into a nightmare. But it's a very nice engine, it has a very low center of gravity, and you still have the power of a V configuration engine, but it has a low center of gravity, so your handling isn't getting spoiled either. Now that we've finished talking about the different types of engine designs, now we're going to talk about the parts of the engine and what each part does. Now, I'm not going to be focusing on any of the engine accessories like the alternators, what charges the battery, or the AC compressor for your AC, or power steering pump, or even the transmission. I'm mainly going to be focusing on the engine. So, let's get started. This part, this black piece right here, that stops at this line, this black piece, going all the way here with this silver piece, this entire piece is the block. Now this is where the cylinders, connecting rod, and the crankshaft are located. You'll soon get to know what this is when I start going over the internals. This part is the oil pan. Now this is where the oil rests after going through your valves and your crankshaft. This is where it rests. So this is where your oil will rest after you pour it in through here. This part is the head. Now the head contains the valves and the camshaft. So as the camshaft turns, it opens and closes the valves, and it's located right above the block. Now between the head and the block, you have something what's called a head gasket. Now this prevents oil or coolant from getting into your combustion chamber, and it seals the head from the block. Same thing up here, which is your valve cover. This piece is your valve cover, and then there's a gasket going around it. Now this is the valve cover gasket. This keeps oil from getting all over your engine bay and is what seals the valve cover from the head. And it's this piece right here. And the valve cover just covers up the valves and the cams. And down here you would have an oil pan gasket, again to prevent oil from leaking out of the engine. This part is the flywheel, and this is what connects with your transmission. Now just two more things before we move on into the internals. I wanted to mention this part, and this is where your exhaust will come out of, as well as have the air get sucked into for your combustion process. So you would have like an exhaust or an intake manifold here. And the second thing I wanted to mention is that if you have a V or boxer configuration engine, now because there are a set of cylinders on each side, you would have two heads and two valve covers on each side. So unlike this inline engine, which has a single head and a single valve cover, in a boxer or V configuration engine, because it has a set of cylinders on each side, there would be two heads and two valve covers. But there would be one block, obviously, and one oil pan. And yeah, that's essentially the exterior part of the engine. Ah, yes, the internals. So let's start from the bottom and work our way upwards. So we have the flywheel, which is what is connected to this piece, which is the crankshaft, and this piece would connect with your transmission. So then we have the crankshaft, and this is what will turn when your cylinder goes up and down. This piece over here is the connecting rod. So as the cylinder goes up and down, this is what causes the crankshaft to turn. So if I demonstrate, you could see as the cylinder goes up and down, it causes the crankshaft to turn, and the connecting rod is what connects both pieces. This part is the valve. So this is the valve. So this is what opens and closes for your engine cycles, which is going to be the last part of the video, and it's also the next part. This is the valves, and this will open and close. So one side will be your intake, which as a matter of fact is this side, and then you have your exhaust valves, which is on this side. Now you might be asking, Haik, how do you know this? Well, this engine has something called variable valve timing. And what happens is when the engine reaches a certain RPM, a certain revs per minute, this piece, which is an actuator, it's actually hydraulically controlled. This is what will change the timing profile and will allow this part, which is the intake valve, to stay open for longer, so your engine will actually have a much better combustion, therefore giving you much more power. So it will be able to move the piston up and down much stronger, giving you a lot more power. So the more air, the more power you will get out of your engine. And then this part is your timing chain. So this is what hooks the crankshaft to the camshaft. And the camshaft is this piece. So as this turns, it opens and closes the valves, as you guys can see. And these are your little arms. In an older engine, you would have your rocker arms and your springs, but this engine doesn't have it. So this is your valves. These are your springs for it to go backwards and forwards on its own. This is your camshaft, valves. This is your timing chain. Now some cars will have a timing belt, but this one has a timing chain. And as the crankshaft turns, it turns the camshafts, which open and close the valves. And the positioning of the camshaft and the crankshaft need to be precise. So as the crankshaft turns, the opening and closing of the valves needs to be just right. Otherwise, your engine will get destroyed. That's why you always have to replace your timing chain or timing belt, because if that goes, then it's goodbye engine. Your engine is gone. And this is your camshaft gears. This piece, this plastic piece or this metal piece, is your timing chain guide. So this is what guides your timing chain. Otherwise, it would just go flopping around. And yeah, so you got the cams, you've got the valves, and then you've got the camshaft gears, timing chain or timing belt, its guide, the crankshaft. Oh, and I also forgot to mention the cylinders. And this is the part where when the combustion happens, it'll move this piece downward, as you guys can see. So now that we've talked about the types of engine designs and the parts of the engine and how each of them work, now we're going to talk about what causes the cylinders to move and what happens inside your engine when it's running. Now, I'm going to try to keep it simple and not get too technical, and I've been trying to do that throughout the entire video. I don't want to get too technical because I know a lot of the people watching my videos will probably not understand this, so I only go over the most important parts and I skip some of the more technical bits. I try getting to the main point. So now let's start. So we're going to be paying attention to these middle two cylinders. So these last two cylinders don't pay attention to, so we're only going to be paying attention to these middle two. So when you turn on your engine, there is multiple types of strokes. You have an intake stroke, a compression stroke, a power stroke, and an exhaust stroke. So let's look at them. So now this is a 4-stroke engine, and a 2-stroke engine would do that exact process that I just said, but in 2 strokes. I get that a lot. A lot of people do ask me, what is the difference between a 2-stroke engine and a 4-stroke engine? Well, the difference is that a 2-stroke engine does the intake, compression, power, and exhaust in 2-stroke, and a 4-stroke engine does that in 4 strokes, that exact process. So this is a 4-stroke engine. So when you start your engine, and it's not always going to be in this position. It could be in any position. So this is what's gonna happen. So you have what's called an intake stroke. So your intake valves would open, and your cylinder would move downwards, therefore sucking the air. Now this next part is the compression stroke. So this is where the valve would close. All the valves would remain closed, and it would compress the air. So as the cylinder moves upwards, it compresses the air. Now, at this point, this is where the fuel would get injected and the spark would ignite, and this is where the combustion would occur, causing your cylinder to move back downwards. And this would be called the power stroke. Now, as the cylinder moves downwards, it comes back up, and this is known as the final step, which is known as the exhaust stroke. So this would push the exhaust fumes out of the engine, and this is where the exhaust valve would open. So pretty much this part of the video is the steps of the engine. So let's do it again. So we have the intake stroke. Now it closes. Now we have the compression stroke. Now we have the power stroke. And finally, as it opens, the exhaust valve, then we have the exhaust stroke. And the cycle repeats for all of the cylinders, and it repeats over and over again, and this is how your engine would run. Well, that wraps it up for this video. Thank you guys so much for watching. More videos should be coming in the future, but otherwise, stay in tuned. I just want to thank you guys again so much for watching my videos. Stay safe out there, and I'll see you guys in the next one.